lesson, we're going to identify polynomial functions. We're also going to understand the relationship between degree and turning points. Classification of a polynomial by degree. Let's talk about the graph of a polynomial function. Polynomial functions of degree 2 or higher will have graphs that are smooth and continuous. Smooth meaning the graph will contain only rounded curves, no sharp corners as you see in the second figure or second demonstration there of polynomial graphs. And continuous means that you can, with your pencil, let's say if you were to try to draw the graph from left to right, if you can draw it without lifting up your pencil, then that graph is said to be continuous. It has no holes or breaks in it, such as in the figure 1 of the graphs, the two graphs that you see demonstrated below. So the first graph represents there a graph of polynomial functions which are smooth and continuous. And then the second demonstration there or figure shows graphs that are not smooth and continuous because they have either a hole or break in it, or they have sharp corners or sharp turns. Now let's talk about the graph of a polynomial function. The graph of a polynomial function can be determined by the function's degree, which can be either even or odd, and by its leading coefficient. So let's first talk about the function's degree. So the degree of a polynomial function is, if you were to look at all the terms within the polynomial function and their degree, so for example, the first term has a degree of 4, the second term has a degree of 2, the third term has a degree of 1, and the last term, the constant, has a degree of 0. So out of all those degrees, the term with the highest degree is the degree of the polynomial. So in this case, the highest degree is 4. So therefore, this is a 4th degree polynomial, which means it is even. And based on that, we know that with even polynomial degree functions, which you will find later, are those type of functions where both ends will either be facing up or both ends will be either facing downward. Now, in terms of what determines whether it faces upward or downward, that would be the leading coefficient. Now, the leading coefficient of the polynomial term is the term that is in the front, the term that has the greatest degree. Now, since the 4th degree term is the greatest degree of the polynomial, its coefficient then would be the leading coefficient. What do we mean by coefficient? Coefficients is the numerical part of the term. So if you look in front of the variable, you have the numerical part. So the first term has a coefficient of 2. The second term has a coefficient of -9. The third term has a coefficient of 4. And the last term has a coefficient of -12. Now again, the leading coefficient is going to be the term that has the highest degree, and we've already established that this is a 4th degree. Now, the coefficient of that term would be your 2. So therefore, 2 is the leading coefficient, And since that is a positive number, that indicates that this polynomial, if you were to graph it, it would be a graph where it would be rising from left and it will fall down to the right. So it would be a graph where you would, again, from left to right, you would see a rise because the leading coefficient is positive. And we'll talk about those things in the coming slides, but for now, all you need to know is to be able to identify the degree of a polynomial function, and that means, again, out of all the terms within the polynomial, whatever term has the highest degree is the degree of the polynomial. And that coefficient of that polynomial is the leading coefficient. Here are some examples of some polynomial functions of degree or higher. You may already be familiar with many of these polynomial functions and their degree. So the first one here, we have a quadratic function which has a degree of 2, cubic function degree 3, quartic function degree 4, quintic function degree 5. So you can even tell by their names what their degree are, and we will talk more about this in the coming slides. Turning points. A polynomial function will often have turning points, and it is the point on the graph where it is going from increasing to decreasing or vice versa. Let's take a look at this graph. And actually, let's look at the algebraic function itself. So here, this is a polynomial function because anything of degree 2 or higher is a polynomial function. What is the degree of this polynomial function? Well, recall that if you look at all the terms, it's which one that has the highest degree. So notice here the highest degree is a degree of 3, so this is a third degree polynomial. And because that coefficient of that polynomial is 2, a positive number, this is a graph that is going to rise up from left to right. But if we'll just follow that graph and keep going up, soon that graph is going to take a turn and it goes from increasing there to decreasing. So that turn or curve we just did is what we call a turning point. So that's one turning point. And if we'll continue along that graph without lifting our pencil, we'll see that the graph goes from decreasing back to increasing. That's another turn or curve in the graph, and that's that second turn. So this graph has 2 turning points. Now, if you are not given a graph where you can readily see that, yes, there are 2 turning points, if you're just given the algebraic function and asked to determine what is the number of turning points in that polynomial, all you have to do is follow the formula of n minus 1. And n is the degree of the polynomial, and since this polynomial is a third degree, it would be 3 minus 1, which is 2, and that tells us that you would have 2 turning points, which we already saw as I followed along the graph. So again, if you're not given the graph and you're just given the algebraic function and asked to determine the number of turning points, it is simply n minus 1, n meaning the degree of the polynomial minus 1. If you're given the graph, of course, all you have to do is look at the point on that graph where it changes from increasing to decreasing or vice versa. And there you have it, turning points. In this example, we're asked how many turning points does the graph of this polynomial have? Now, we are not given the graph, we're just given the algebraic polynomial function, so we have to look at all the terms to determine what is the highest degree. So notice the first term has a degree of 5, the second term has a degree of 3, the third term has a degree of 1, the last term does not have a degree because there's no variable there. So out of all those degrees, the highest degree is a degree of 5. So this is a 5th degree polynomial, which is an odd degree. Now to find the number of turning points, it is simply n minus 1. And if n is 5, that's 5 minus 1, which is going to give you 4. So when we draw or sketch this graph, we can expect there to be 4 turning points. So let's take a look at what that graph looks like. And as we can see, there are 1, 2, 3, 4 turning points on this polynomial graph. And there you have it, turning points.
Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.